Hello, can you make a video for Dowel's connector? How to make more quantity than one and with good space between them? Thanks. Yeah, I think we could do that. So first we're going to jump into our connectors library. Go over here and create a new one. So we're going to start off with a dowel. So from there I'm just going to call this standard. Why don't we call this dowel standard, like so. And from there we're going to input some values. So let's make this 1 millimeter. Our dowel is going to be 30 millimeters long. And this is going to be 8.5 to give a little bit of offset. And then finally we'll make this 5 millimeters. Cool. So there is our dowel. If we want to import a physical dowel into this connector, we can do that as well, because right now this is just covering the machining. So we're going to go ahead and hit the check to save that to our library. So there we go, standard dowel. And now I'm going to create a part. So I'm going to go Control N for new part. And I'm going to pick a part, but Z up. This is important. Your Z orientation plays a big role when creating one of these connector hardwares. So I'm going to go ahead and select Z up. And that basically just orients my origin in a fashion so that Z is oriented up. So yeah. Now I'm going to go ahead and create my physical model for my dowel. So I'm going to make this. My dowel is 8 millimeters wide. And then I'm going to extrude this out. And I want to extrude this from the mid plane 30 millimeters. And yeah, this could be good enough, but I think we could take this a little bit further. I'm gonna put a little chamfer on both sides of this face. Maybe do 1 mil, and I'm going to do the same on this side as well. Okay, cool. And once again, I want to go ahead and add an appearance here. So what I will do, we can do, let's go ahead and take this to material. We'll edit material, and I want a SWOOD specific material. And we're going to choose, this one will work. Just pine. So cool. Now we have an appearance. Actually, my material itself is pine, and we're going to go ahead and save this part. Where you save this is important. I'm going to save this to my SWOOD library, and I want to save this in my hardwares library. So that's over here. And is this the correct one? No, it's not. I want this. SWOOD design, hardwares, and I have a dowels folder already created. So I'm just going to go dowel, and I'll do 8 millimeters underscore 30 millimeters. Cool. I saved my part there. So now I'm going to jump back over to my connector, which is over here. Edit that. And I'm going to come to this window here for component. And I'm just going to go ahead and insert that component that I just saved and created there. So perfect. We went ahead and created my dowel. So I saved that to my library. And now I'm going to jump back over to my box and test it out. So when I drop this in, what this should look like, I should just have one single dowel in the middle of my two intersecting panels. So this guy and this guy. And it's just a coincident intersection. It's not like overlapping panels. So I go ahead, drag this down, and I actually have this oriented in the wrong direction. So I want to reverse that like so. And cool, when I hide that, I can see that my dowel is there in place. And yeah, that's looking good. And that is half of the equation. So our requirement is we wanted to be able to add more than one, and we wanted to be able to control the spacing. So we're going to jump back over to our connectors library, and we're actually going to create a new, and we want component pattern. So we'll call this Dowel pattern, PAT for pattern. And what we're going to do, we created that Dowel standard, and we want to drag that feature because this connector that we created is what we want to pattern. So I'm going to drag this over, pull this over, and now I have a pattern object Dowel standard, which is great. Cool. So from there, yeah, there's a couple things that I need to create. So basically, I want to be able to control how many dowels I have in place, and I also want to be able to control the spacing. So we need to add a variable for that spacing specifically. So what we're going to do, we're going to call this, so we're just added a new variable, a distance variable, and I'm going to call this distance from edge is the alias, and the name itself, we'll just call this distance from edge. Perfect. So great. I have my variable there. That was one thing that I needed to create on this screen. And now I'm going to jump over to a script. So we're going to do a little bit of scripting for this guy. So in particular, I have a script that I've created that will allow me to kind of control those values and where they are in place. And I can explain what those mean here in a second. So I'm going to go ahead and use my snipping tool to grab that code. There we go. So this is the one that I want. Go ahead and drop this into place. And we can kind of walk through this. So when looking, let's see if I can actually have to accept this first. Okay. And I can look at my script on this screen. Okay, perfect. What we have going on. So RNXP, we check into our variable list here, stands for number in positive direction. What that is doing, that is just adding a connector in the positive direction of the default value. P.X, P stands for position, .x represents in the x-axis. So as you can see here, our x-axis is represented in red, kind of aligns with our coordinate system that we have in our default SOLIDWORKS models. So P.x is set to 0 in this if statement. So basically, if we have our positive, what is it, RNXP, so our number in positive direction is set equal to 1, then P.x is 0. So P.x is represented in 0, and that just comes default dead center. So our if statement has an else attached to it. So basically, if that RNXP value is anything other than 1, then we run this other sector. So long story short, what this P.x value is basically doing is creating an offset from the center value and instead sending it to one of the edges. So if our value was 2, it would, instead of being from here, it would be over here. RNXM is our negative, no, not that one, RNXM is number in negative direction. We always want that to be 1 for this example. Because if we were to do that, then it would start sending connectors off the other side of the panel intersection, which we don't want. We want all of our connectors to be where our connections are located. And based on the way that I configured this, we always want that value to be 1. Finally, what we're doing for step, and step is basically the distance in between these connectors. I created a formula that basically always orients the distance between this to be equal to the distance between this. So if I have 3 connectors, this distance and this distance is going to be set equal. So as you can see there, this formula is doing that. Yeah, please feel free. I'm going to go ahead and copy this script into the comment of this video. So that way that you guys can just copy this script and paste it into your script editor. Yeah, if you guys have any questions, feel free to leave it in the chat and I'd be happy to answer those. We input this code that I figured out a while ago that allows you to add a connector type and basically create that variable distance from edge, and then you can define that variable from edge to edge. So we're going to jump back over to that distance from edge value, and we want to make this exposed. So basically what exposed means is whenever you go to insert your connector, you have that value over here on the right. So yeah, right now we have that set as exposed. If we made it private, when we jump over here, it's going to be missing. But we do want that exposed. So we want that. And why don't we make the default distance just be 2 inches, like so. So now when we jump over, that value is default. Okay. And now we are looking for, we want our other value, which is RNXM. No, we want RNXP. We want RNXP to be our other visible value. And when we change this value, you could see like, oh, okay, sweet. That added 2 connectors. I add 3. Now I have 3 connectors. And it's kind of spaced like I have 2 from the edge. And that's defined by that distance from edge. And I can show you over here. So if I change this to 3 inches, you can see those values on the ends are now changing. I made this 1 inch. Oop. I made this 1 inch. Those values on the end are changing. And now if we add 4, we could see, okay, sweet. Now this is evenly spacing out my connectors. If I made 4, if I did 5, it's evenly spacing them out. If I do 6, same deal. So yeah, your options are kind of limited or unlimited when you use this type of configuration. So we're going to make this distance from edge. We're going to do 2 inches like so. Number in positive direction, we can leave that at 3. And we want to make sure that that default value, RNXP, that value is typically 3. So we're just going to save that. So now we can take that dowel pattern and we can drop that into our connector, just like so. And we can see, I can make this, transparent so I can see those connectors in place. So you can see, sweet, I have 3 dowel connectors, or 3 dowel machinings as well as connectors in place. Like if I go ahead and let's say I wanted to isolate this, let's change transparency and isolate. You can see that that machining is in there as so. But I do want to leave this transparent so you can see what's going on. So now we have connector 1. Well, actually, I overlaid 2 connectors on top of each other, so I'm deleting that connector 1. So I'm going to edit this feature. So now you can see that distance from edge value. I could change that to 3 inches if I want. And we can change this number in positive direction to 4. And now I have 4 dowel connectors just like so. So yeah, there's that. And the nice thing, so the important part where I saved this hardware type, that dowel, in my hardware folder in my SWOOD design library, is now when I import them into my library, they now import into my hardware folder. So it comes fairly organized. Not only is that a perk, but when I do go and run my SWOOD report, these dowel connectors will be counted up. So let's say I have like 15 cabinets that all have these dowel connectors, just like so. Basically, my hardware is all going to be accounted for when I run my report. And I don't know how many that would be. You know, let's say I had 15 cabinets and, you know, I had dowel connectors in each intersecting cabinet. I'll just make up an imaginary number. So let's say I had like 500 of these. I wouldn't have to manually go in and count all of them. They just show up on my report. So yeah, that's basically that connector pattern. And yeah, I hope that answers your question, homie. Stay tuned for next week's video. Catch you guys later. Peace.